All right, well, welcome back. This is the third of 5 videos exploring Chapter 7 in the most excellent textbook of Security Risk Management, so by Wheller. And so what we're going to do is look at 12 core communications services. We'll start off by looking at communications inspection. And as the name implies, you're just looking at the communications, making sure that the appropriate rules are being followed or whatever criteria you've got set up. Typically, this is going to be done in the lower levels because it's faster. So you're looking down there across the actual media. You're looking at the network traffic where packets are being routed, and then you're looking at the end-to-end connections at the transport layer to move things along. A vulnerability exists when something is processed at these levels where the data is in unencrypted format, and then a threat can take advantage of that. You can do it at higher levels, but it's going to slow things down. And with network traffic, you typically don't want to do this. For communications inspection, often you're looking for covert channels that are out there. All right, validation is going to be our second core service. And this is where we're validating the protocols that make sure that those protocols are actually being followed. And before we go too further, protocol is actually just a set of rules. It's a set of standards or codes that define the communications between two or more devices over the network. Okay? And you're trying to make sure that that communications takes place. So again, this is typically going to be at your network transport layer, and you're validating that the communications is taking place and getting to the end, and you're not losing traffic or someone's not inserting traffic. There are lots of things that you can validate. The size of the data units. You're looking for parameter changes in the header or footer, typically the header. You're looking to see if things are out of sequence at the session level, or if there's a replay attack at that level. Looking for integrity checks if there's encrypted data, and then the overall format of the data being extended. What you're really trying to do is make sure that authorized communications is taking place and that you don't have either a denial of service or you've got data leaving your organization. So in our organization, we filter looking for PHI, credit card, SSN type of traffic, and then filter based on that, not allowing that to leave the organization. All right, when we look at policy enforcement checks, lots of things that you can do to make sure that the communication devices, your computing devices are up to standard. So you can check to see that the anti-malware, antivirus is installed, active, and up to date. You can check patching against the operating system, Adobe, and common applications. Make sure that the device that's on your network is either owned or controlled by the network and it has the appropriate configuration. Someone hasn't turned off the antivirus to play League of Legends, for example. That you don't have any infections out there. And so lots of things you can check through policy enforcement. Lots of different actions indicated in that second column. You can block or reject the device joining. You can limit their privileges, move them off on the guest network, for example. Automatically remediate what's going on. Typically, you don't do that, but you can because that automated remediation takes time. That means you're actually going to patch the machine before you allow them to log in. And typically, there's some reporting tied to that. Session management is going to be absolutely critical. The session ID has to be protected and encrypted. If that is released, someone can interject traffic into that, and so you've got to make sure that it is not changed and that it is not read. If it's in plain text, the whole session is going to be compromised. Lots of different attacks are listed down there in terms of caching, bookmarking of it using predictable indicator values. But I think you get the idea when we're talking about sessions, which is that kind of you've got multiple applications connecting across and communicating, and you're keeping those sessions separate. You want to make sure that those session identifier is protected, that it's encrypted, and that you're making sure that you're running your sessions correctly. There are lots of different principles associated with this, one of which is to have a limit on the number of concurrent sessions. Otherwise, you can have a user inadvertently launch the denial of service attack on you. We had this happen actually last week at our university, where a person in SharePoint opened up 64,000 files, and it caused havoc with the system. Sometimes you want to be able to issue a session lock, and that means you want to relock that session after a period of activity, and then revalidate the person if it's just been sitting there doing nothing. You won't automatically want to terminate sessions if they're inactive, and you want to cycle through your IDs periodically or have unique IDs in some particular case. If you can do these types of things, you create the opportunity for doing single sign-ons. When you think about single sign-on, you should be thinking about session management. It's allowing you to extend that one session across multiple applications, lots better security, lower cost. You're integrating where they're signing in once, and then, at least for normal operations, they're able to get into all of their normal applications they're trying to use. As we're talking about that logging in authentication, there are really three ways that you can do this. You can see that in that graphic on the left. It's something you know, like a password. It may be something you have, like a smart card or a token. Or it may be something you are, some biometric component associated with you, like a fingerprint or face geometry or eye scan, any of those types of things. And so as we're thinking about authentication, these are going to be those factors that come into play. When we're thinking about authorization, we're talking about what type of access do you get once you're actually logged into the actual system and what you can do. And we talked about this earlier in the course, in terms of the insider attack and someone having the ability to do backups, but then using that to get into the student information system and sell grades. Moving to a different type of service that's out there, auditing and logging to perform accountability is one of those things absolutely critical. You can see over in the right pane the target attack, and as you can see, the system actually fired. It detected that they were under attack and that credit cards were flowing out in that step 4, but they did not act on it. They thought it was a false positive. So you do want to make sure that you're logging information, but not only logging, but someone's paying attention to it. There's lots of activity associated with this which make it difficult. You probably want to send it to a central repository. You probably want to have it on a central timestamp. And you want to be able to cross-reference between different applications, events that are occurring as you're trying to figure out what happened in an attack. And again, as I mentioned, and as evidenced by the target attack, you actually want to pay attention to it when you have your systems start to indicate there's something wrong, and that was based on going through their log files and detecting what was happening. My goodness, cryptography is one of these key services, and we get to cover it in one slide. Typically, there are two functions, encryption and hashing. Encryption can be done two different ways, symmetric or asymmetric. Symmetric is using a single key, as indicated in the top part of the graph. And the advantage to it is it's really fast, it's very simple, but it's very hard to distribute that key. In asymmetric encryption, you've got two different keys, a secret key and a public key, and they're mathematically related. It's much slower, much more complex, but it's actually quite easy to distribute keys. You're seeing some systems today that are a hybrid between the two. At their heart, they're a symmetric encryption system, but they're using asymmetric encryption to distribute the keys. A great way of doing that. I haven't mentioned hashing. Hashing's a one-way encryption function that generates a unique key associated with whatever was passed into it. Resilience is going to be making sure that you've got availability of that infrastructure out there. And again, very challenging to perform when you look across the entire enterprise. If you just look at your network coming in, you want it coming into two, and I'll use a university as an example. You want at least two different network connections, each of them coming into different buildings. as your connection to the internet is distributed to all the buildings on the campus, each building, same thing, you want 2 different connections, so if one's cut, you don't lose internet connectivity, and then when it gets into the building, you don't want it all going into one room, but you actually want it distributed in the building so that you don't have a single point of failure. You've got to have physical redundancy, and you've got to have logical redundancy as you're looking at this. As you can see on the slide, there are lots of ways of doing this and what you've got to look at. You could have hot, warm, or cold sites out there. If you don't have a dedicated mechanism to hot, warm, or cold, you could use a shared mechanism using timeshare or mutual arrangement, co-location. As you're looking at resiliency, this gets expensive, and this ties into business continuity. So typically the CEO is going to be involved with decisions around resiliency. All right, this brings us to event monitoring, and that goes back to the auditing and logging, is that you've got to actually look at this, and you've got the same characteristics that we talked about. You want to normalize it across applications, make sure you have normalized timestamps, and be able to pull that together and use it to make decisions about what's actually going on in the system. Ultimately, you want to know what's normal, what's abnormal, and what do you do when something abnormal happens. That's the root of audit, logging, and event monitoring. This brings us to vulnerability management. So vulnerability management is going out and making sure all those things are patched and that people are doing what they're supposed to be doing in terms of keeping those devices all patched up. A lot of the attacks that occur, if you're actually patched, the vulnerability has been addressed. It's just difficult when you've got tens, hundreds, of thousands, or even millions of devices out there to make sure everything's patched. And there are automated tools that allow you to go out and scan to make sure that things are being patched, you've got the right security controls, your policies are being implemented. All right, and that brings us to the last. This is an in-class exercise. Because this is a video, we'll kind of cut to the chase as you look at these two. What's better, that daily scan or monthly scan? Option 1, option 2, what could it be? Well, you know what? It's actually option 2. Option 1 is a version of a denial of service attack on yourself. You're giving your users about 15 minutes to come in the morning and work, and then after that, that Nexus scan is going to scan every IP address, and you'll definitely notice that impact on your traffic. Typically, it's done monthly, but you do want to follow up. The other challenge with scanning everything at 8:15 in the morning, typically something like that for a large enterprise will finish about 4. You'll have 15 to 30 minutes to close out whatever you found, which means you don't close anything out, and then you just start another scan. So there's very limited functionality there. All right, well, very good. We've talked through the kind of 12 core services in our technical controls. What we're going to do and pick up in the next video, our 4th video, by looking at recommended controls. So keep on studying, keep on learning. Look forward to seeing you in the next video.